Hello, everyone, and welcome to the Rhombus Energy Solutions and IoTecha webinar on smart charging, the key to unlocking revenue opportunities for medium and heavy-duty electric vehicle fleets. I'm going to spend a couple minutes to go through the, kind of introduce the speakers and go through the agenda really quickly and walk you through the ground rules. My name is Mike Human. I'm the VP of Marketing at Rhombus Energy Solutions. So we're going to have two short presentations, one by Rick Sanders and Joseph Gottlieb of Rhombus, then followed by one by Oleg Logvinov of IoTecha. After that, we'll have three panel questions, and then we'll have an audience Q&A session wrap up right around 10 o'clock. If you have questions and answers, you can put them into the Q&A window in Zoom. We'll hold those to the end, but feel free to put them in whenever you want to, and we'll just go ahead and answer those all at the end. The other thing is that we are recording this webinar, and so we will send out the recording to everybody who registered, along with the PDF of the slide set. So let me introduce our panelists here. We have four people with us. Rick is the CEO and co-founder of Rhombus Energy Solutions. We also have Oleg Logvinov, who's CEO and co-founder of IoTecha. He's joined by Michael Macaluso, who is the EVP of Engineering and co-founder of IoTecha. And then the last co-founder we have is Joseph Gottlieb. Joseph is the CTO and co-founder of Rhombus Energy Solutions. And with that, let me pass it to Rick.
All right, thank you, Mike, and thank you all for joining today. Let me give you a little overview of Rhombus. Rhombus is an industry leader in advanced power conversion. Our core technology is deployed in a number of different market segments, including DC fast charging, which we'll cover a little bit more today, energy storage solutions, and microgrids. Rhombus is headquartered in San Diego, California, with a high-powered test lab and manufacturing capability in Dearborn, Michigan, as well as an Indian design center. All of our power stages are bidirectional, and that gives us the flexibility to integrate renewables, energy storage, and enable V2G charging. Our products are easily customized, and we have a UL certified lab in Dearborn that gives us the ability to not only customize, but also recertify products quickly and bring to market. We can also do private labeling. We have deployed over 820 systems worldwide, mostly in the US. And because we're one of the few companies that provide bidirectional charging capabilities with 1741 SA standards to push power back to the grid, we're one of the leading experts in the V2G charging arena. Thank you. With that, let me turn it over to Joseph for the next few slides.
Thanks, Rick. So we'd like to discuss what is a smart charger. And what we're talking about is, originally as EV chargers were first kind of conceived, it was a pretty simple concept. You plug a charger into a vehicle and it puts energy into the vehicle. But as technology progresses and as requirements by the grid and by other services progresses, these things had to change. And so now we have smart charger capability, which means we can actually talk to the vehicle, communicate with the vehicle, get vehicle information and vehicle data. We can have database capability to characterize and sort and store data from both the vehicle and from the grid side, multiple interfaces with upstream systems for back-end services and for maintenance services, different software components, and perform extensive self-diagnosis on these systems because their uptime needs to be very high. These are utilized in needs to be utilized 24/7 essentially in some cases, and so you need to have those capabilities on board. And so optimally, a smart charger has the resources to run additional applications as the future kind of progresses. And manufacturers and third parties come up with different ways of monetizing energy going into and out of a vehicle and data in and out of a vehicle. So some of the difficulties is that a smart charger has to have multiple communication paths, meaning it has to be able to talk to a whole host of different pieces of equipment and services to be able to get this to function properly. The most important is the 15118 communication to the vehicle, which gives a high-speed data link to the vehicle's information and all the details needed there. It needs interfaces for measuring, monitoring, and metering for demand energy, behind the meter factory demands, integrating to other systems, communications to an aggregator platform and back-end service providers. And it's, you know, a lot of different ways the communications have to go in these systems. There's a lot of certifications that these chargers have to meet. As we had mentioned, we're leading with a 1741 SA, with also the HECO requirements for Hawaii and California Rule 21 requirements, you know, to be a best in class, first out to the market with all of these capabilities for complete bidirectional integration with all sorts of different use cases for the energy and for, as I mentioned before, the monetization. And the smart chargers have to be designed for today's requirements and for those of the future. We've all seen some of the early chargers deployed way back in the day with the Avcon paddles. Those have all been torn out, defunct, and done. If they had, you know, a little more smarts to them and capabilities to be upgraded, they might have lasted a little longer. Next slide. So some of the use cases for a smart charger is vehicle to grid. You can interface with a vehicle, fleet scheduling software, and utility aggregation software, really allowing you a complete kind of system that you can save money in certain cases. You can improve your scheduling and capabilities. And again, more information about the system at hand for optimizing in the future. Integration with energy storage systems, where you can interface with storage battery systems. You can interface with energy management software, PV solar inverters, an entire microgrid universe that you can connect to and be able to interface to, again, mainly for reducing the cost of the energy consumption and optimizing your fleet maintenance capabilities and your fleet management capabilities. So in both cases, you know, there's a lot of data that has to be moved from the vehicles to external systems and from external systems to the charger itself. The charger is the ultimate gateway to the vehicle itself and to the utility. So it's a very critical piece of the puzzle to be able to communicate to these different systems and be able to operate in these different environments. And finally, you know, the Rhombus family comes in multiple power ratings. We have a 60 kilowatt unit, a 125 kilowatt, and a 500 kilowatt. All of our chargers are bidirectional V2G capable with 1741 certifications and all the rest of the certifications to make it a bidirectional EV charger. Our dispensers can be remote up to 600 feet from power conditioning systems with options to go even further if you need it. And rated for outdoor use in the most demanding conditions. As Rick had said, we kind of came up in the industrial inverter market space, and we've had a lot of units deployed in those areas. And so we know a lot about units that have to run 24/7, power converters that have to run 24/7 and have a very, very low failure rate and low issue rate. And so that's where, you know, our focus to these products has been. And again, with the added bonus of having many years of doing the V2G services on energy storage, this is you know, a great segue for us to be able to produce these kind of offerings. So I thank you.
Perfect. Thank you, Joseph. And let me switch over to Oleg. Again, Oleg is the president and CEO of IoTecha. Oleg, take it away.
Thank you, Mike, and thank you, Rhombus, for organizing this event. This is a great opportunity to share what we know, what we have learned in doing V2G. Actually, I would like to call it V2X because the spectrum of applications is quite broad. But I would like to start with probably the reasoning why everybody sees on this webinar today Rhombus and IoTecha presenting together. We're working in a complex environment, and I absolutely agree with Joseph. Charger is a gateway between not just the vehicle and the power. It's a gateway between two different worlds. It's a gateway between the world of transportation and the world of power, the world of energy. Those two worlds really never worked together. If you look at conventional forms of transportation, what we see is basically a lot of dispensers spitting out either diesel or gas, maybe even some forms of low pressure gas, but in any case, it's a combustible fuel. And the infrastructure that delivers electron really never connected to the vehicle. For the first time now, we're experiencing this tsunami of electrification that collides those two worlds, and all of a sudden, the gateway between the two of them, the gateway which is electric vehicle charger, becomes an important element. That's where IoTecha came from. IoTecha came from essentially an IoT world, Internet of Things world. When we recognized that at some point it is going to be a massive informational data type of issue, how to connect the two worlds, we thought that our expertise in designing power line communication technology called HomePlug, the one that underlies communication enabled by ISO IEC 15118, is going to be exceptionally important. It's something that will allow the two worlds to understand each other and connect with each other. And that's how the idea of IoTecha came to be in 2016 when we launched it as a company. So our goal is to simplify this transition. Our goal is to make transition from combustible fuels, something that emits dirty carbon into the air, into the world of clean transportation, very easy. And that requires an application of Internet of Things to enable those massive gateways that will be deployed in the world in millions of units to work smoothly and operate with two worlds, worlds of transportation and charging. And IoTecha today is an expert in providing components that help our customers to build chargers, AC and DC, and provide cloud services to make total cost of ownership of those chargers as low as possible. We're a B2B provider. You will not find our technology with our brand anywhere, but you will find our modules and our technology, our cloud, behind many applications and thousands of chargers around the globe today. We work quite closely with applications of V2X. From our point of view, V2G is just one of the components, vehicle to the grid, but vehicle to home, vehicle to load are also quite exciting applications. And vehicle to vehicle application is a very interesting one in the fleet context. We truly believe that combined charging system, CCS in other words, with ISO IEC 15118 is a fantastic platform to enable those technologies. Next slide, please. So if you look at the portfolio of our products, we provide modules for the vehicle side that implement CCS with all of the necessary communication. We provide modules for AC and DC chargers. We provide actually complete branded chargers that we bring to market with our customers and partners. We have something very unique. It's very unique tool in the industry. We're actually the only company that provides this tool that allows us non-intrusively monitor communication between the vehicle and the charger and decode communications that is using 15118. The reason we can do it is actually quite simple. Mike and myself, we were among the team members who created HomePlug powerline communication technology some number of years ago. And we developed this technology, we developed the silicon that we're using today, and when we spun off from STMicroelectronics, we had all of the portfolio of tools necessary to build such a product. And of course, our cloud that allows connectivity with a PKI infrastructure so we can enable plug and charge, as a whole provides a complete vertical solution for anybody to start business. Next slide, please. I would like to mention this product that we're bringing to market in December in collaboration with our partner ECS Elite Group. And this is going to be one of the most advanced, if not the most advanced, chargers in the US market. It is a 20 kilowatt device with our IoT technology inside. It is enabled with ISO IEC 15118, with V2G and plug and charge functions, cloud connected with all of the possible connectivities inside of this device. So stay tuned. Pretty soon you'll see the announcements that this charger is commercially available. And for us, it is exceptionally exciting news because not only it enables the most attractive and the most advanced services, it also provides an opportunity to start experimentation with V2G on a massive scale. And next slide, please. So why V2X is important? Well, V2X is important because the economics of how energy can be delivered to the vehicle are different from what we're experiencing today with the world of fossil fuels. We believe that electrification of transportation not only opens the door for cleaner environment, but it also opens the door to new business models that are driven not necessarily by somebody paying for electrons, but connection between the charger and the vehicle and the cloud and the energy grid creates an opportunity for new benefits and new services. And especially bidirectional power flows that enable us to create effectively microgrids behind the meter, create opportunities for a tremendous optimization. So if you think about from the point of view of consumers, fleet operators, employers, energy companies, and automotive guys, there are opportunities to monetize the charging itself. How, you would ask? I'm not going to bore you reading those bullet points. You can do it offline, but I would like to give you actually two examples. Next slide, please. Recently, we demonstrated together with Lucid in New York, California, that a vehicle parked at the office in New York, California, if you apply the rates provided by PG&E to that facility, can actually generate $50 to $100 worth of value on an annual basis. And that's incredible, because if you think about the economics of buying a car that potentially costs you, let's say $70,000, but this car is capable of producing $25,000 worth of value in 5 years of operation, that changes economics. It's no longer a $70,000 car. It's something very different. And that is exceptionally important. That creates a business opportunity. And actually, it has been recognized by McKinsey. If you look at the studies that I cited below, they talk about that charging services that will be there for fleets just in the US alone could become a $15 billion business by 2030. And that's pretty close. That's not future. It's basically a few years ahead of us. So we need to be cognizant that charging is not just what we need in order to enable vehicles to run on the road. It's actually an opportunity to create new monetization streams, new opportunities that drive the business forward. Next slide, please. Of course, there is going to be a discussion. Which way of integration is better? Are we going to integrate it as DC hubs, where basically all of the sources and consumers of the energy will meet at the DC line, or vehicle will discharge energy at AC and put it into the AC grid? Personally, I think that both models are valid, and each one of those models will have its own applicability. As an example, wouldn't it be nice, as an example, to have your vehicle, your passenger car, capable of discharging the energy so you actually don't have to have backup storage for your home when power disappears? I think it's a fantastic opportunity, very convenient. At the same time, if you look at the chart presented earlier by Joseph, when we talk about large-scale fleets, probably it is reasonable to say that DC approach with a DC bus is the right application. Next slide, please. So what are the challenges? What do we need to solve here in order to make it all work? This is a very simple slide, but if you look at it, there is something very important in it. We need to enable economy of scale. And I'm very happy to say that today, combined charging system supported by Charging Alliance, which is a global organization of over 200 companies, is widely adopted in US, Europe, and many other countries around the globe. So that creates an opportunity for OEMs to go forward and without any hesitation use CCS with ISO AC 15118, plug-in charge and grid connection and B2G capabilities widely without any concern. But then, talking about the same challenges of becoming a gateway, the charger needs to interface to multiple ecosystems. Mike, if you can click one time, and those ecosystems connect us to, as an example, the grid itself directly, connect us to what is happening behind the meter, what's happening, as an example, with interfaces to the home energy management, building energy management system, integration that provides us with a lot of convenience to Alexa, Google, Apple, Samsung ecosystems. All of that needs to be adaptable and flexible, because depending on the application, depending on the region, depending on what type of customer we're serving, we need to provide this flexibility. So that brings this challenge of chargers serving as a gateway to the forefront of our discussion. We need to have this intelligence, and that's where Internet of Things come in play. How to do things in a way that enables us scalability on one hand and adaptability on the other, which is a key component of this development. Next slide, please. And if you look at the anatomy of a DC charger, it's basically very clear that this type of gateway function is absolutely utmost important. That's how we created our modules. We created our modules to give us a tool to drive, essentially in a very simplistic way, how the rectifier or inverter or bidirectional charger would work from the power electronics point of view, and provide very simple interface to engage that device. But on the other hand, it is all about the ability to communicate with multiple data actors and integrate with multiple types of systems that can essentially orchestrate, not control, orchestrate, because control on such large scale will not be possible. It's orchestration. How they can orchestrate power delivery to a variety of chargers, whether we're pursuing behind the meter optimization task or grid scale stabilization. It is big data problems that we need to be cognizant of and provide a platform for solving. And I think that was my last slide. Thank you very much for your attention, and I look forward to discussion with fellow panelists and our participants.
Excellent. Thank you very much, Oleg. So with that, let's get to the first panel question. And that panel question is, how critical are smart chargers to use cases like V2G or integration with stationary energy storage resources or renewable energy resources? I'll throw that out to the group to answer.
Yeah, Mike, this is Rick Sander. I think that smart chargers are critical for V2G applications, or as we talked, integration of renewables or energy storage for the future.
Yeah, I'd like to add on that. You can't do it without it. You have to have the smart charger, because the smart inverter space, right? I know everybody's kind of has some familiarity with the solar space, and so everybody went from standard solar inverters to smart inverters. And so now we've got chargers, now we're moving to smart chargers, and that gives the ability for the V2G capability and V2x as well. Again, going to off-grid capabilities and different functions like that, as Oleg had mentioned. And so I think it's critical that you have those communication links and those capabilities to really handle the ecosystem. Again, as Oleg had mentioned.
Yeah, I think I fully agree with what Rick and Joseph had said. If you look at why smartness is needed, well, it is an informational problem, right? The way we need to plan the energy delivery, the way we need to manage the distribution of the energy, the way we need to align, as an example, planned routes, especially for the fleet vehicle, with the capacity to serve the grid. It is not possible without intelligence components in every link and every component of this chain. And that's what necessitates the charger to be smart.
Exactly. If you look at the system that's so complex with so many actors, you have a lot of information that needs to be exchanged. You have different capacity of the grid varying at times. You have different varying demands from different vehicles, from multiple vehicles, especially looking at applications where you have fleets or depots where you have large amounts of vehicles and potentially also large amounts of storage available. Orchestrating all of that that energy flow would really be impossible unless a system could understand what energy was available in different different vehicles for reverse power flow, what the capacity of the grid was at the time, what pricing models looked like, what demand charges looked like, and to provide the customer with a seamless experience. A lot of information is needed, and you can't really have that information exchange without, let's say, with some, let's say, dumb device. You need to be able to support renegotiation, because depending on the assumptions that the vehicle has of what's available, it might change its charging profile. It might want to charge more or less, depending on price models. And being able to manage the energy flows at a higher level, as Oleg mentioned before, orchestration is really key, because you can imagine so many different actors and so much control would be a really difficult problem to solve, let's say, from a central point. So orchestration of multiple systems is really key to enable the coordination of energy flow to keep the customers happy, deliver what needs to be delivered, and also save energy and save cost over time.
Certainly all very good things. Let's jump to the second panel question, and that question is, when charging medium and heavy duty electric vehicle fleets, what are the major concerns that fleet operators should look for when selecting a charger solution? Why don't we start with Oleg on this one and kind of go through the panel backward this time?
Well, let's think about a fleet. A fleet is a combination of several things. It is, yes, a collection of batteries and wheels on one hand. It is a collection of vehicles that have to go on routes and be able to operate within what they have been assigned, which basically means that they need to be able to drive a certain number of miles every day. And of course, it is a maintenance resource that we need to apply to those fleets and understand how they're performing. So how does smart charging help in each one of those cases? Well, first of all, remember I mentioned about a plug-in charge feature of ISO AC 15118? I'll give you one very interesting example. Talking to one of the fleet operators, they told me, look, we would love to know how much energy is consumed very specifically by each vehicle, and we would like to align it with our planning so we know how to use a vehicle as a resource. But what we don't want to do is to manage this through essentially participation of drivers or technicians. So we don't want a driver to be responsible for swiping an RFID card or punching some kind of code. We would like to completely automate this process. So combination of smart charging with plug-in charge, where vehicle basically gets automatically authenticated by the system, and authentication effectively enables data exchange, and now we know which charger connected to which vehicle, what is the idea of this vehicle, and how the charging process goes, becomes an exceptionally valuable tool for combining smart charging with effectively operational platform or fleet operator. If you look from the point of view of combining, as an example, the same operational platform with an energy platform, so you can actually do intelligent forecasting of what a vehicle would need depending on which assignments it got for the next day, or how much the energy was depleted today, what is the state of charge of the battery. You now can run optimization and figure out how to best use this vehicle as an energy resource, so you can actually not only minimize your demand charges and potentially reduce some battery charge from one vehicle by discharging to another, so you can avoid demand charges from the grid. You can actually serve as a stabilization resource to the grid. And examples like that are numerous, but none of that is possible unless you have the smarts in the charger and the vehicle itself to enable it.
Yeah, so building on what Oleg just mentioned, it kind of relates back to the first question as well, related to smart charging. Especially if we're talking about fleet operators, intelligence and smarts is really key, because if you think about managing such a large amount, a large fleet, for example, Oleg mentioned before, dealing with RFID cards and things like this, automation is key, right, for a system to operate efficiently. We can't really effectively rely on operators or drivers of the fleet vehicles to do the right thing, to badge the right vehicle, to enter the right vehicle ID, to have the right card, so that the system can be managed. And if you look at ISO IC 15118, with functions like plug and charge, so plug and charge is a secure way to authorize vehicles to charging stations. There's multiple models of operation. One is, of course, the public model, which relies on public PKI infrastructure and clearinghouse and e-mobility operators. But there's also private plug and charge deployment models, where fleets, for example, can engage in such a program. So a private plug and charge option for a fleet operator is very interesting because not only it protects their vehicles or their charging infrastructure from foreign vehicles, and not only deploying energy to vehicles that are authorized to charge, not just with an RFID badge, but actually built into the vehicle, authenticated to the vehicle itself, while maintaining standards compatibility. And it gives the ability to really get the accurate information, because information is important, but accurate information is essential to get the accurate information as far as what vehicle is there, what the capacity is, what its route may be, and how to manage all that energy planning. So, so from our point of view, this intelligence is really key, and functions enabled in ISO IEC 15118, such as plug and charge, really make that really enable that feature and enable it securely for the fleet operators.
Yeah, this is Rick Sender. I'll add to that. I think in a fleet, obviously, the cost of electric vehicles are quite expensive. For a transit bus, it could be $500,000 to $800,000. Those assets need to be efficiently utilized, and they need to be available to run routes when you have to run routes. And so charging takes time, and it's a one-to-one connection, and you need a reliable charger, right? You need a charger for fleet applications that's robust, that has high reliability uptime, that can be maintained easily. You also, as you plan out your fleet, it's quite complex, and there's a lot of uncertainty of how this is going to unfold. And you really need to future-proof. You need to buy chargers that have the flexibility that gives you the options in the future to integrate renewables, to integrate energy storage, to offset your demand charges as required. These assets with large battery packs are significant energy storage assets, opportunities to get a revenue stream on.
Yeah, this is Joseph. I'd just like to add, from my perspective, one of the most important things is it has to run when you plug it in. It has to always run when you plug it in. And it has to run for very large amounts of time at very high power rates. So, that's the first, criteria is it needs to be robust. It needs to work. And underlying that, it needs to have the communication capabilities to make sure that it's going to maintain operations. If there's anything that can be predicted before issues occur to be serviced, that can be scheduled in, those are the critical kind of pieces. And then, of course, the cost function of the energy itself, making sure that you can get that energy when you need it at the price point that you can afford. So those are the big criteria that I see and the major concerns that fleet operators need to look at.
Thanks, guys. And let's jump to the third panel question, and then we'll go into the audience Q&A. And that third panel question is, how important is it for smart chargers to be able to run third-party applications, right? We're used to open systems we can put third-party applications on different systems, whether it be smart TVs or set-top boxes or phones even, or whatever. How important is that for the smart charger market? And we'll start with you, Joseph.
Right. Yeah, that's pretty important. And I'll give you a couple examples of that. Again, going back to the energy storage market space, each utility behaves slightly different. Each operator has a different goal in what they're trying to do. Some operators, the electricity cost isn't the issue. Others, it's critical. Others want to integrate it into their building management systems. So, they've got a large depot that they want to operate these units in, and it needs to be able to interface and run an application that integrates it into building management so that it can control turn on and turn off times, not to all happen at the same time or coordinate so they can reduce their demand charges. So the AC unit doesn't turn on the same time as 3 chargers, all right at the same moment. So, that makes it pretty critical for those type of applications. And then on the consumer side, there's different presentations of the charger. There's chargers that are there to advertise. And so they're, charging systems that their strict function is to give you some advertisement through either its own screen or porting it down to the vehicle screen, to try to get, kind of the visibility, because you're sitting there for potentially a little bit longer than a standard gas fueling right now. So those type of applications, really need to be capable and put into these systems relatively easily. Again, with the data management as well. Some customers want more details out of the vehicle itself, but they're not necessarily going to want to give their magic sauce to it. So they want to put an application down inside that extracts that data and transmits it to their system, in their own way and their own capabilities. And the utilities also have their different requirements and applications that they'll want to run locally on the ground as well.
Well, I would like to jump in, and this is Oleg, and maybe slightly modifies the question. It's not about applications, it's about services, right? Whether we run those services with native application inside of the charger or allow third parties to plan their application, that's a different story and probably requires a completely different discussion. But certainly, without a doubt, I fully agree with Joseph. Running third-party services is absolutely utmost important. Well, in fact, if you look at the charging industry today of charging infrastructure, it's very common to find the case where hardware is manufactured by one company and central server is provided by a different company. The interface between the two is called OCPP. And OCPP is what allows the charger made by company A and cloud services provided by cloud B work together. So what the focus here should be on is interoperability. Interoperability on the interface between the charger and the car, the interface between the charger and the cloud, multiple clouds, the ability to connect to multiple service providers, whether it's a service provider that controls charging process or service provider who offers the ability to integrate with a grid or behind the meter optimization, home energy management system, in this case, advertisement server. I mean, the list is probably quite endless. But it is very important for the charger to be able to support those interoperable and open interfaces that allow us to have integration with a wide variety of services. That's actually where most of the revenue, most of the opportunities for monetization will be created. And that's what is needed, interoperability.
And also, I think to that point as well, the ability for smart chargers to be field updatable and remotely managed and remotely maintained and configurable is absolutely essential, because, as we're talking about complex technologies and also, talking about multiple different services that we deploy on different chargers, I agree with both, what Joseph and Oleg had mentioned, that you find yourself existing in different environments. There could be different home energy management systems, like mentioned, EE-Bus, for example, or building management systems. There's a variety of those. And especially looking at larger operations like fleets, the requirements and the scheduling and all of these things will be different for each one of those. So configurability and remote maintenance and the ability for the devices to be updated is also, extremely useful and essential to manage these smart chargers. Because another point that we didn't really touch on here as a topic yet is interoperability with vehicles. As the market grows and as more vehicles come to market, there is more and more interoperability testing and potentials for interoperability issues that happen. And knowing how vehicle manufacturers operate their update cycles, deploying updates, in some cases, of course, vehicle manufacturers use over-the-air updates and do them quite frequently. But for a lot of them, it's not done very frequently at all, only when there's a service call or when it's brought in for maintenance and there's a ECU update available that's pushed. So typically it's reliant upon the charging infrastructure to adapt to what the vehicles are doing. And in order to do that, being able to manage them remotely and update them is absolutely critical, and also to provide new services.
Yeah, I would just add a couple points. Our operating system that we have designed and developed over the last 4 years that make our inverters smart has a high-level API that we designed specifically for this, so that third-party applications can write applets that can be easily interfaced and abstracted from the hardware layer, making it easy for third-party applications to run and interface and orchestrate with the smart chargers.
Absolutely. And I think it certainly, illustrates the point that if you don't make your chargers or any devices programmable, whether it's to run new applications, new services, or adapt to changes in those things, right, their life cycle ends up being pretty short. And for something as expensive as a fleet, medium, heavy duty EV charger, that's a big issue. So with that, let's jump to the Q&A section. We have 2 questions about ISO 15118. The first question is, I heard ISO 15118-20 will not be backward compatible with ISO 15118-2. Is that correct? And if so, which will you support? Now I'll let IoTecha answer this first, and then we'll go to Rhombus.
Sure. So I'll take this one. This is Mike. It's if you look at the ISO 15118 communication between the vehicle and the charger, the initial part of that communication is a session setup and what's called a protocol discovery. So it's been designed already to support multiple standards and multiple chargers, and that actually happens now. Early EVs that were deployed were actually using DIN spec, which is a DIN 7121, which was effectively a light version of 15118-2 that was ratified before ISO could publish an ISO standard, because that takes a lot more time. So while it is true that the actual messaging of -20 is not backward compatible with -2, they're fully interoperable and compatible because both the chargers and the vehicles will implement both sets of messaging and automatically choose what's supported and negotiate between them on start. So that's the first, answer to the first question, and then we will support both. On our charger side, we'll support both, so we can talk to any vehicle, whether it supports DIN spec, -2 or -20.
Yeah, I think that's from Rhombus' perspective, that's the easiest answer, is that first initial connection that the car makes. It basically indicates what it's going to be, and then chooses from there.
Very good. And then the next question is, I think you guys have probably already answered this, but we'll just throw out there and you can say, yeah, that's covered by the last answer. How are you guys managing the implementation and deployment of ISO 15118 since the latest version is still to be finished?
So yeah, this is Joseph. What we are doing is following along the same lines as what we've seen 20 will become in general. So we are able to implement, I would say an intermediary version for the V2G and V2x testing pieces. And we're working with different vehicle manufacturers that are working with that as well. So that's kind of how we're getting to that point. And then once the standard is finalized, everybody will move over to that.
Yeah, this is Oleg. From IoTecha's point of view, it's very similar. We evolve our stacks with the evolution of the technology. And as Mike said, we started with DIN, then progressed to next version of 15118, and now progressing to -20, and so forth and so forth. That's the fun of being in the world of IoT. evolution of protocols and communication stacks never stops. They evolve, they improve, and then continue to innovate. And that's why the expertise in this area is very important. And that's why IoTecha was created. That's what we do.
Very good. Thank you. Let's go to the next question. That is for V2X applications. Who does the monetary benefit go to? Is it shared between the grid, end user, and aggregator? And building on that question, who bears the cost of battery life degradation caused because of various V2X services?
Well,
go ahead, Oleg.
Okay, I'll be happy to start. I think there is no single answer to this question. It depends on the business model. It depends on arrangements. It depends on what exactly somebody's trying to accomplish. So if you look at the fleet as an example, and most of the optimization that is done is behind the meter. So in other words, you never have a negative power flow through the meter. What you're doing is essentially you're managing your own charging through elimination of demand charges by leveraging lower tariffs and so forth and so forth and so forth. So that's one model. Another model is to look at batteries as a distributed energy resource and grid stabilization resource. And as an example, when you have negative energy cost, like in Germany as an example, during some of the sunny days, you have the ability to absorb energy and the utility will pay for it. So it totally depends on how you structure it, how you evolve the business model in this case. And in terms of degradation of the battery, there are already studies that show that actually V2G impact on the battery degradation is de minimis. So as we go forward and battery technology will continue to evolve, I think this question will disappear by itself.
Yeah, I'd like to add, again, on the degradation part, there is two main functions of that. My background is actually in the lithium packaging from previous company. And as a lot of people know with the Nissan Leafs that came out, a big portion of it is not necessarily the utilization of the battery, but the temperature of the batteries in those particular cases. So there's a lot of, parameters go into that qualification. And so in general, a lack of use is also can degrade the batteries as well over time. So just having those units sitting out there, school buses in the summer, just sitting out there not being connected is, even more of a risk in particular. So that's something to kind of keep in mind. And again, there's a lot of work being done now on second life use of those batteries, where there is more energy in those batteries to be utilized at a later date. So there's a lot of different mechanisms going into that particular issue that's getting worked on right now.
Very good. Okay, our next question is for medium-duty, heavy-duty EV fleet management. Would all the data available over 15118 meet the needs, or is additional information from the EV required? And if additional information is required from the EV, are powertrain and EV suppliers on board with sharing this information with the aggregator or fleet management company? Why don't we start with you, Joseph, and then we can switch over to Oleg and Michael and Rick.
Sure, that's an interesting question. So if you're talking on the fleet side, then the fleet manufacturers, the truck manufacturers, if they are wanting more information through that pipeline, they can certainly do that. There are mechanisms inside there to transmit other data that would be required for the aggregator or fleet management. Most of the information is already there. It's there's a very large, healthy dose of information that's available from the vehicles to the platform. But there may be other information that the powertrain and manufacturer suppliers want to gather as well. And again, that's why we were talking kind of about that third-party application or services. I like that as a better word, Oleg. The services, that can be added in, and it's not a difficult prospect to do that. It's not necessarily standardized. And again, there are the vehicle manufacturers that are very protective of certain data, but they still want that data to come out, and they can still have that come out through 15118.
Yeah, I agree with Joseph's point, and we also have to remember is that the way 15.11.8 is designed, it allows us to increase the scope of the data that can be exchanged between the charger and the vehicle, because we also have the opportunity to have, as an example, custom data fields and custom data structure or vendor-specific data structure introduced into this process. And I think the true answer to this question is very simple. It all depends, once again, on the business model. If we have a good reason, as an example, for a fleet operator to acquire more data from the vehicle because it improves the total cost of ownership of the fleet, I'm pretty sure that OEM supplying the fleet with vehicles will be quite open to do so. And by the way, think of it in a slightly different way. It is all about competition, right? Competition forces technology providers, product developers to offer additional things to their customers that improves the ownership and reduce the cost of ownership for such products, right? And that's exactly what it is about. So if, as an example, if there is a developing trend that says, well, if, as an example, vehicle provides certain additional data components, it becomes easier to project, as an example, and plan charging process, which helps the operator to reduce the cost of energy applied to all the vehicles. Guess what? You will see this feature supported by pretty much everybody who is in this business. Competition does a lot of positive things, and it's important to keep in mind that in interoperable platforms that enables competition is the key. That's what enables the economy of scale and every possible feature to be pushed beyond the boundaries.
Very good. I think we have time for one more question. Let's jump to this one. It's, are the V2G / bidirectional communication messages finalized within the ISO 15118 protocol so it can be more widely implemented by EVSE manufacturers and EV OEMs? Well, we start with you, Oleg, or Michael, and then we can go to Joseph and Rick.
I will let Mike talk about it.
Sure. Yeah. So this is so for 15.11.8, -20, which is the next version of the specification, is ongoing right now. There are several drafts that have been that are circulated, internally to the ISO group, and this is what is being used by all of the auto OEMs right now, and the pilot programs that are running now to test and evaluate 15.11.8 and test and evaluate bidirectional. But 15.11.8-20 finalization will be sometime early next year, and that's when all of these things will be made available in the public standard. So it's an ongoing activity. It's a very active community that is engaged in finalizing all these messages and all of the data exchange. And yeah, it'll be available in -20, and it will be fully, that's the whole point. One of the major use cases of -20 is enabling bidirectional charging.
And just to, don't forget that, these units are field updatable, field upgradable. So you can get the hardware out there and deployed. And as this protocol gets finalized and gets implemented, this stuff can be remotely updated to handle the new communication protocols or whatever changes need to be made.
And I think that actually brings a very important point into the focus. When we talk about charging infrastructure and assets such as chargers, we have to keep in mind that cloud connectivity is of paramount importance. We have to treat those devices as Internet of Things devices that need to be updatable over the air, monitor them over the air, and evolve them and actually improve their profitability as we go forward. And that is not possible without reliable and robust cloud services.
Agreed.
Very good. And so thank you, everybody. Just as a quick reminder, we will be making a recording of this webinar available on the Rhombus YouTube site. We'll send out a link to that site as well as a copy of the PDF of the slide set to everybody in the next day or so. And again, thank you for joining us. If we didn't answer your question, I apologize. And we'll try to get some of those answers out to you guys later on. But thanks again for everybody joining us. Thanks to our panelists. And I hope you have a great day. Thank you.
Thank you.
Thank you.